Hi students, how are you? In last class, we were discussing about the role of atmosphere in climate control. And today, we can take the next page. And here you can see one activity 14.1. So first we can look at this activity and discuss these question answers. Activity 14.1. Measure the temperature of the following. Take a beaker full of water, a beaker full of soil, a closed bottle containing a thermometer. So three things are needed: a beaker full of water, a beaker full of soil, and a closed bottle containing a thermometer. Keep them in bright sunlight for 3 hours. Now measure the temperature of all three vessels. Also take the temperature reading in shade at the same time. Now answer these questions. First question. Is the temperature reading more in activity 1 or 2? We can see that the temperature reading is more in activity 2. Then second question. Based on the above finding, which would become hot faster, the land or sea? You can see that temperature of soil is more than the temperature of water in bright sunlight. Then third question, is the thermometer reading of the temperature of air the same as the temperature of sand or water? We can see that the temperature of air in shade is different from the temperature of soil and water in bright sunlight because of the direct effect of radiations in the second. Then what's the next question? Why does the temperature have to be measured in the shade? The temperature should be measured in the shade because in the bright sunlight, direct solar radiations will affect the thermometer reading, which will not be uniform. Then the fourth question is the temperature of air in the closed glass vessel or bottle the same as the temperature taken in open air? You will observe that the temperature of air in the closed glass bottle is more than the temperature taken in the open air. Then next question, what do you think is the reason for this? Answer is, it is due to greenhouse effect. The solar radiations enter the glass bottle through the glass walls. However, the re-radiated rays cannot pass through the glass and they heat up the air inside the closed glass container. The next question is, do we ever come across this phenomenon in daily life? We come across this phenomenon of greenhouse effect in our daily life. For example, when a car parked in the sun, it gets heated from inside due to greenhouse effect. Then our next topic is about the movement of air, that is wind. So the moving air is known as wind. We have all felt the relief brought by cool evening breezes after a hot day. And sometimes we are lucky to get enough rains after some days of really hot weather. What causes the movement of air and what decides whether this movement will be in the form of a gentle breeze, a strong wind, or a terrible storm? What brings us the welcome rains? All these phenomena are the result of changes that take place in our atmosphere due to the heating of air and the formation of water vapor. So now we can look at activity 6.2 in your textbook. That is to demonstrate that air currents are caused by the uneven heating of air. So the activity is, place a candle in a beaker or wide-mouthed bottle and light it. Now light an incense stick and bring it to the edge of the mouth of the beaker or bottle. Observe the direction of flow of smoke. In next step, Keep the lighted incense stick a little above the candle and note the direction of flow of smoke. Keep the lighted incense stick in other regions above the beaker or bottle and again note the direction of smoke above the beaker or bottle and again note the direction of smoke. You will observe that the direction of flow of smoke is different when lighted incense stick is kept at the edge of the mouth of beaker and if it is kept a little above the candle and in different regions above the beaker when the incense stick is kept at the edge of the mouth of the beaker. The smoke will flow towards the candle and then above. We can see the smoke always move towards the candle and then move above. When the incense stick is placed at different regions above the beaker, the direction of flow of smoke will be towards the candle and then upwards. So here first question is, which way does the smoke flow when the incense stick is kept near the edge of the mouth? What is the answer? We can see the smoke will flow towards the candle and then above. And what is the second question? Which way does the smoke flow when the incense stick is kept a little above the candle? Then answer is smoke will flow towards the candle and then above. Then third question is, which way does the smoke flow when the incense stick is kept in other regions? Other regions we can see the air above the candle gets heated and rises, creating a low pressure below. So air from adjacent cold areas moves towards this low pressure zone. Okay, so this shows air currents are caused by the uneven heating of air. The patterns revealed by the smoke show us the directions in which hot and cold air move. In a similar manner, when air is heated by radiation from the heated land or water, it rises. But since land gets heated faster than water, the air over land would also be heated faster than the air over water bodies. If you look at the situation in coastal regions during day, so daytime, what happens in coastal region? So if this is the land and here this is the sea, which becomes hotter fast during daytime due to the heat of sun, we know the land becomes hotter faster. We have seen that. So the air above the land, so land becomes hotter, so the air above land becomes hotter than the air above sea. So when the air becomes hot, it begins to rise up. So the air above land rises up. And when air rises up, here what about the pressure in this region? Here the pressure will be low pressure. And we always know air always move from region of high pressure to region of low pressure. So here when the hot air rises up, the pressure becomes low. What about the pressure here? Pressure is high above sea, the pressure is high. So we know air always moves from region of high pressure to low pressure. So what happens? Air from sea moves to the land. And what about the air above sea is cool. So cool air from sea move to the land. So during daytime, what happens? Cool air from sea will move to the land. And this is called sea breeze. So we call this sea breeze. So wind from or breeze from sea is called sea breeze. So cool air from sea moves to the land. And when it is taking place? It is taking place during daytime. So during daytime, what happens? The land becomes hotter faster than water. So the air above land is hotter than the air above sea. And when the air above land becomes hotter, it rises up and creates a low pressure here. When here the pressure becomes less, air from this region, here the pressure is high. So cool air from sea moves to the land. So during the daytime, what is the direction of wind? Wind moves from sea to the land. And that is called sea breeze. Is it clear? Now, we can look what happens during night. So during night, what happens? During night, this is land. Here this is sea. So now we can look what happens during night. So during daytime, we saw that land becomes hotter faster than water. But during night, no sun. So both water and land begins to cool. And land cools faster than water. So land begins to cool faster. So the air above land will be cool. What about the air above sea? It becomes cooler slowly only. So it will be, air above sea will be hotter than the air above land. So the air above land will be cool and the air above sea will be hot. And we know hot air rises up. So the air above sea rises up, creates a low pressure here. Then cool air from the land moves to the sea. So wind is moving from land to sea. So this is called land breeze. Okay, so land breeze means cool air moves from land to sea and it is taking place during night. Okay, so during daytime, what happens? Cool air flows from sea to land. That is sea breeze. And during night, what happens? Cool air moves from land to sea. And that is called land breeze. Okay. So, we know in coastal regions, during the day, the air above the land gets heated faster and starts rising. And as this air rises, a region of low pressure is created and the air over the sea moves into this area of low pressure. And the movement of air from one region, that is from region of higher pressure to region of lower pressure, that is called wind. So moving air is called wind. So we saw how land breeze occurs and how sea breeze occurs. Okay. And all the movements of air resulting in diverse atmospheric phenomena are caused by the uneven heating of the atmosphere in different regions of the earth. So one reason for wind is what? Uneven heating of the atmosphere. Some part will be more hot than the other regions. So that hot air rises up, that will create a low pressure, then cool air from other regions will flow into this region. So all regions are not equally heated. So uneven heating of the atmosphere in different regions create wind. But various other factors also influence these winds. So not only uneven heating of the atmosphere causes wind, there are some other factors also. And one factor is rotation of the earth. So earth is rotating. So due to rotation of earth also wind occurs. And another reason is the presence of mountain ranges in the path of wind. So big mountain regions are there. So when the wind flows, that will go and touch the mountains. And when the mountains act as a block, it will change the direction of the wind also. So which are the factors for wind? Uneven heating of the atmosphere, rotation of the earth, and the presence of mountain ranges in the paths of wind. Our next topic is rain. So you know how clouds are formed, how rain is formed and all. That all you know. So now we can discuss how clouds are formed and bring us rain. For that, there is an activity in your textbook which demonstrates some of the factors influencing these climatic changes. That is activity 14.3. First, we can discuss this. Now, we can look activity 14.3. Take an empty bottle of the sort in which bottled water is sold. Pour about 5 to 10 ml of water into it and close the bottle tightly. Shake it well or leave it out in the sun for 10 minutes. This causes the air in the bottle to be saturated with water vapor. Now take a lighted incense stick. Open the cap of the bottle and allow some of the smoke from the incense stick to enter the bottle. Quickly close the bottle once more. Make sure that the cap is fitting tightly. Press the bottle hard between your hands and crush it as much as possible. Wait for a few seconds and release the bottle. Again, press the bottle as hard as you can. Now, look at these questions. So, we can look at the questions. We can find out the answers for these questions. This simple experiment replicates on a very small scale the happenings when air with a very high content of water vapor goes from a region of high pressure to a region of low pressure. When bottle containing water is kept in the sun, the water evaporates and air inside the bottle gets saturated with water vapor. When the bottle is pressed between your hands, the pressure inside becomes high and air inside the bottle moves in a region of low pressure. It expands and cools. The smoke particles act as nuclei on which water vapors condense in the form of tiny droplets. When you release the pressure, the air inside the bottle becomes foggy. When bottle is again pressed, the fog will disappear. It is so because due to high pressure condensed, water vapors will fall down and collect as water at the bottom of the bottle. When the experiment is repeated without smoke inside the bottle, one will not observe foggy air inside the bottle as smoke particles are absent and nothing is available in air to act as nucleus for water vapors to condense as tiny droplets. So the above experiment replicates on a very small scale what happens when air with a high content of water vapor goes from a region of high pressure to a region of low pressure or vice versa. When water bodies are heated during the day, a large amount of water evaporates and goes into the air. Some amount of water vapor also get into the atmosphere because of various biological activities. This air also gets heated. The hot air rises up carrying the water vapor with it. As the air rises, it expands and cools. This cooling causes the water vapor in the air to condense in the form of tiny droplets. This condensation of water is facilitated if some small particles could act as the nucleus for these drops to form around. Normally, dust and other suspended particles in the air perform this function. Once the water droplets are formed, they grow bigger by the condensation of these water droplets. When the drops have grown big and heavy, they fall down in the form of rain. Sometimes, when the temperature of air is low enough, precipitation may occur in the form of snow, hail, or sleet. Rainfall patterns are decided by the prevailing wind patterns. In large parts of India, rains are mostly brought by the southwest or northeast monsoons. We have also heard weather reports that say depressions in the Bay of Bengal have caused rains in some areas. Then our next topic is air pollution that we can discuss in next class. Okay, bye.